So this session will be on distributed computing. As you all know, this is one of the main branches of cloud computing. And I am Malinga Perera, working as an associate tech lead in data analytics team in Cisco Labs. So when we see these kids in universities, this one quote that came to my mind. This from a co-founder of Netscape, a board member of Facebook. Every kid coming out of Harvard, every kid coming out of school now thinks he can be the next Mark Zuckerberg. And with these new technologies like cloud computing, he actually has a shot. We all, you and me, who are products from schools and universities, has this big dreams one day to become next Mark Zuckerberg. But in the past, the opportunities were so slim. But with nowadays technologies, the toolings and all these open source softwares and tools, I think every one of us has a shot to become the next Mark Zuckerberg. Having that in mind, let's start the session. So what's distributed computing? If you check this example, it shows that to transform 1 gigabyte of data to information, it takes 1 day. And when the data grows bigger and when it becomes 2 gigabytes of data, it takes us 2 days to transform the data into information. So what we can see here is, if we are keeping the hardware the same, and if the data set is increasing in size, it will take more time to process those information. And there will be a point it's not possible anymore. So that's where the distributed computing comes in. Now the data sets are so big that we cannot rely on one machine or one box to transform all those data into information. So now we are using distributed computing where we distribute this data set among several machines, and we'll do the computation in all of these machines to finally come up with one set of information. And I like to present you another challenge that we have right now. That's real-time analysis. Earlier days, we are used to do this batch processing, where we process information once in a day, maybe overnight. So a lot of banking systems, a lot of data transformation systems out there use this batch processing, where we process all the information nightly, maybe weekly, maybe monthly as one big batch. But nowadays, the requirement has changed a lot. A lot of applications now requires real-time processing of information. So in this example, it talks about a power system simulation, where we want to know what will be the power requirement in the next few minutes so that we can generate the required power. You might have heard that it's really important to keep the generation as well as the requirement in balance. So it's extremely important to know what will be the load requirement for the next few minutes. However, to do this, you need to process the latest possible information. You might get a lot of information all across the world, and you might have to process all of them to know what will be the requirement for the next minute. And even if you go to a very simple example like Google traffic, where we want to show the real-time traffic updates, it's really important to know what events happening right now and process all this information so that we can come up with the real-time traffic information. Not only in power systems or traffic information, we see a lot of scenarios where we need to process the data immediately and real time. So today we are talking about a ETL framework which can distributively process all the information in real time. So this ETL framework will use Apache Spark. Here we have shown a simple topology where we take data from one place and do a transformation and load somewhere else. That's what ETL means. We extract, we transform, we load somewhere else. To get a better understanding, let's understand what is Apache Storm and what are the main components in Apache Storm. So Apache Storm, you might already know, is a Apache software which is open source, and this is well known for stream processing. And if you have requirement to build something like a production line where you process set of data as steps, you do some kind of transformation, you hand it over to the next step, and in the next step we do another transformation. Like that, at the end we save the end result. So in Storm we have several main components. Let's start with the spout where we extract the data from a stream. So this is the data source for all the topologies. And thereafter we have vaults where we can use vaults to do some kind of transformation. If you can see in the first example, we have shown that for all the t's in these tuples are marked in red. So that's the transformation we did. And we can do mergers where we merge two tuples into one. So all processings in topologies are done in vaults. Finally, the concept of topology, where we join all these spout and then a lot of balls to create a transformation line which finally will load that data into some other data source. So if we connect all these components and make topology, we will get something like this. So what I have shown in this example is we are taking data from HDFS, a Hadoop distributed file system, and then we are applying some filters on that data. We are doing some MySQL lookups, and we are doing some aggregations, that more or less summarization of data, and finally we are storing that in a MySQL. However, these steps might have their own speed. The overall speed of a topology depends on the slowest step. In this case, it will be the filter vault, where it can only process 10 tuples a second. So the overall speed of this topology will be 10 tuples a second. But the good thing about Storm is you can add more workers to a given step. So say if there's a slower step, you can always increase the number of workers who's actually working on that step. Storm will make sure he will distribute this work among the cluster, and we don't have to worry about that. So say we added 2 more workers for filter vault, so we will get a topology like this, where we can see now we have 3 filter vaults resulting in 30 tuples per second, and which will improve the topology speed to 30 tuples per second. So what we did is we built a framework on top of Storm where you can simply write the configuration of each spout board as XML. So we have shown some example XMLs where we can define the parallelism and define the type of the spout. It can be a DFS spout, it can be a S3 spout, and what's the type of the board and what's the parallelism. Like this, you can simply build a topology even if you don't know any programming language, or even if you don't have any technical expertise. Next up, I like to talk about another problem that we solve. That's custom profiling. That's custom profiling. You might have heard that companies like to profile their customers for various reasons. If you take restaurant industry, if you profile your end customers, people who comes to restaurant to eat, you can know what they like to eat, what their favorite times, and what their favorite tables. And if you know this, you can provide customized service to all of them. Think you walk into a restaurant and the person at the restaurant calls you by name and directs you to your favorite table and recommends you few of their newest dishes that you will like. You will have a great user experience. You see a customized service for you. So that's what you get from customer profiling. You get insights to each customer. But the challenge is, we are talking about hundreds and thousands of end customers. If you take only US, a lot of people are eating out. So we are talking about the population in US. So we have to build a solution that can accommodate that kind of high velocity data flow. So in this custom profiling solution, what we are trying to do is, we are trying to use this open source project to transform all this data and create one single profile that we can use in restaurants. I will not go into details about custom profile, but what you can do to keep up with these new trends. I think for all of you, when you come into industry, the single machine computation is not there. When we talk about computation, now it's always distributed. Now we have gone past those limits where we can process everything in a single machine. So you have to keep up with these new trends. So one thing I can tell you is, you can do this in your own computer. You don't need set of servers. You don't need a cluster to do this. So try downloading this stuff and try that in your computer. You can always use virtual machines to work as a cluster. There's no better way to learn things other than trying. So always try and get a first-hand experience by trying out. That will be one tip that I can give you that will help you to keep up with all these new trends. Keep up with these newsletters, keep up with the newsletters sent by these open source communities like Apache, where they will talk about newest technologies which adds to their family. So keep up with this, try this, and you will get better at this. Thank you.